Hey guys, Mr. Wood here. I am in my wife's office. We had a little ER run the other day, but everything is good, and I'm going to be back tomorrow on Thursday and all next week and the week following, God willing. So, what I want to do today in our uh, in our lesson today is I want to go over the lab. So, if you guys could get this in front of you, the specific heat of a metal lab. This is going to be due next Wednesday, Thursday. So kind of the schedule is next Monday, that assignment, the worksheet, specific heat and the problems with it, that is due. And then next Wednesday, Thursday, you're going to have your first big test on chapters 1, 2, and 3. This lab is going to be due and the review sheets. So next week is a big grade week. And I really think a lot of you guys have been following along on our lessons, and there's a few of you that I don't think are, but a lot of you are. And next week is kind of like, this is when we're going to find out if you've been doing it or not. So hopefully you have. So I'm going to do that today in our lesson. So, but of course, jokes. And today I've been at home, so I don't have my joke list. So I teach AP Chem. Maybe you guys. We'll talk about that later, what some of you would want to take AP Chem. But one thing I always do with my classes is I do a class t-shirt. So, and I let them design it as long as it's PG or PG-13. But anyways, this is back in my 2013-14 year, and the front you're going to understand more later, but a polar molecule with a polar bear. But the back, it says, "Flask me anything, I'm a chemist." There's the joke. And then here on the front of my shirt, so this is my 2014-15, it says, "Don't trust atoms, they make up everything." It says, I need my glasses here to read, "You're my favorite person. I wrestled a shark once. My name is Adam." So those are the jokes for today. So Miss Silly, Goofy chemistry teacher, you have. Okay, so on this lab, so again, I'm on this specific heat of a metal lab. And make sure, again, on your labs that you guys show your work, clearly show your work, and watch your sig figs and label. And I want to start off with pre-lab question 1. So down here, pre-lab question 1. And I'm going to do 1, and then you guys can do 2. And you'll have time to ask me questions on this in class next or tomorrow for cohort B, or next week for cohort A and B. And you can always feel free to email me. And if you want to set up just a little Google Meet that we can do on days you're not here, I'm more than happy to do that. But this is kind of a tricky one. So I'm reading pre-lab question 1. Remember, the point of the lab was to figure out the specific heat of the unknown metal, and then to use the specific heat to determine the identity of a metal. So it says 25 grams of metal X at 85 degrees Celsius is dropped into 75 grams of water. There's a lot of numbers here. The final temperature of the water metal mixture is 22.2. Determine the specific heat of metal X. And then it says, using the specific heat, identify it. So I'm going back here to number 5 on the back. Okay, so this is how we do this. So here's my whiteboard at home that I used last year when we were all in quarantine. But here, what we do, this is the chemistry on this problem, is what we do is we say that the Q, remember, Q is equal to SM delta T. Q is equal to SMAT. I might turn off the light here. Okay, I think that's better. So Q is equal to SMAT. Well, what we're saying is that the Q of the W of the water equals the Q of the metal. QM, the metal. And that's one big assumption in this lab, is we're assuming all the heat from that hot metal went into the water. Of course, that's a poor assumption, because some of the heat from the water or from the metal went into the air. But we're going to assume that to do this. So we have the specific heat of the water. So now I'm plugging in the SMAT for the water and then the SMAT for the metal. So the specific heat of the water times the mass of the water times the change in temperature of the water equals the specific heat of the metal times the mass of the metal times the change in temperature of the metal. So what I did is I plugged in the SMAP for the water, specific heat of the water, mass of the water, change in temperature of the water. And then here's the specific heat of the metal, the mass of the metal, and the change in temperature of the metal. Okay, now I'm going to plug in the numbers. Now the specific heat of water is a number that's given. It's actually on our unit sheet. It's 4.18. And the problem says that the mass of the water is 75 grams. And the change in temperature of the water, it was at 20, and it ended up as 22.2. So 22.2 minus 20. Okay, so this is the SMAT for the water. Now for the metal, the specific heat is X. The mass of the metal, it says, is 25 grams. And probably the trickiest thing of all here is the change in temperature of the metal. And it started at 85. And we're going to assume it ended up at 22.2. We're assuming here that the temperature of the water ended up to be the same as when the metal was added to the water. You're going to do exactly the same thing on the lab. So then if I go through and do the math here, so I'll take 85 minus 22.2 gives me 62.8. So write that down here. I have 25, just rewriting this, and X. And then here I have 4.18. I have 75. And then I have 2.2. So I just did the subtraction. And now remember, when you solve for X, you isolate X on one side of the equation. So I'm going to get X all by itself on one side. So I'm going to divide 25 and 62.8 off both sides. And I still am going to watch my units. So if I divide those off the right, I've got to divide those off the left as well. Okay, now if you look at the units, Celsius goes, grams go, and I'm left in the units for specific heat. So if I do this, 4.18, do the math, times 75, times 2.2, enter, divided by 25.0, enter, divided by 62.8, enter. What I get is 0.439. My sig figs, remember whenever you're multiplying or dividing, you go with the number with the fewest sig figs. Well, that's 2. So what I get here, my answer is 4.4, and the unit is all this. It's joules over grams times degrees Celsius. Whoops, I'm sorry, it's not 4.4, it is 0.4. Yeah, 0.44, 0.439, so 0.44. So that's the answer. You're going to do exactly a problem like this in the lab write-up. But not done yet, because it said there was 2 questions here. One was to the specific heat, so we got that. The second one was to identify it. So I go back here to number 5, and what is clearly the closest here is iron. So the identity of this metal would be iron. So we determine the specific heat of the metal and the iron. Okay, so there is pre-lab question 1, 2 answers, and I'll let you guys do pre-lab question 2 right there, and if you have questions, you can ask. Okay, now I'd like to go to the questions of the lab. Okay, so I need to get expo markers. I didn't know I was going to be needing this. But let me just clean this off. Sorry, it becomes a mess. But let me just kind of walk you through the lab write-up itself. And like I said, next week we will have time for you guys to ask questions. My board is kind of a mess. So I'm going to kind of give you a little bit of direction here on the lab write-up. So, okay, so here we go. So for question number 1, and you got to watch this. For question number 1, so again, where I'm on now, I'm on questions. And again, make sure that you show your work. It says calculate the change in temperature of the unknown metals. So for number 1, you're going to go to the data table and we're going to assume, and if you're, well, I'm going to point this out, but in here there's a question on number 6 on the back. It says, what are the 2 assumptions in this lab? Well, if you read number 1 in parentheses, it says, we assume. And then down in number 3, we are assuming. So I just kind of gave you that. So there's one assumption and there's another one. Well, obviously, if we're making some assumptions, then we're going to have some percent error. Okay, but back to number 1. Calculate the change in temperature of the unknown metal. So the delta T of the metal, the change in temperature of the metal, what we're going to do is on the data table, we're going to take the initial temperature, we're going to take the temperature of the boiling water. So what we're doing here is we're assuming that the metal, just like it says there, we assume that the metal's temperature is initially equal to that of the boiling water. And we're going to subtract the final temperature of the water in the cup. And again, what you cannot do in lab write-ups is you can't just give me an answer. You need to show me the numbers and you need to subtract. Okay, so that's how you do number 1. Okay, number 2, so the delta T of the water, the change in temperature of the water, is you're going to take the final temperature of the water in the cup, this same number. So the final temperature of the water in the cup minus the initial temperature of the water in the cup. Okay, so again, watch your sig figs and make sure you clearly label everything there. Okay, and then number 3 is going to be just like the pre-lab question that I did. So number 3, again, we're going to use the Q of the water equals the Q of the metal. We're assuming that all the heat given off by the metal is gained by the water. So we have the specific heat of the water times the mass of the water times the change in temperature of the water equals the specific heat of the metal times the mass of the metal times the change in temperature of the metal. So you're again using that same exact thing. The specific heat of water is a number that always assume that you have. The mass of the water is in your data table. The change in temperature of the water is your answer to number 2, whatever you had for number 2. The specific heat of the metal is X. It's the whole point of the lab. The mass of the metal, again, is in the data table. And the change in temperature of the metal is your answer to number 1. I should say it's your answer to number 1. So this is just like the pre-lab question. So you plug in all the numbers, you go through the math, you solve for X, and again, watch your sig figs and watch your units. Make sure you label with the right name. Okay, and then when you come to number 4, the accepted value, right here, the accepted value, make sure I got this. The accepted value, I think, is 0.89. Yep. The accepted value is 0.89. Okay, so you're going to use 0.89 as the accepted value. The experimental value will be your answer to number 3. So what you got, your answer for number 3. Okay. And if that's a negative number, just take the absolute value. If it's negative, take the absolute value. Okay, and then on number 5, by telling you it's 0.89, I'm telling you that that was aluminum. But I want you to answer number 5 according to your data, what you guys got for the lab. So let's just say you did the lab and you got 0.74. So you got 0.74. So then if that's the case, your best answer there would have been carbon graphite. So again, you base that answer on your data, not on what I told you. Okay, number 6 I talked about. In conclusion, you need to go back because there was 2 problems here. So you need to tell me the specific heat that was determined and then the identity that was determined from your lab. So, okay, so hopefully that is helpful to you guys. And again, if you have questions, feel free to email me. Monday, that assignment is going to be due, so I'm going to collect that worksheet. And I'm going to do a video on Friday, this Friday, kind of reviewing, getting ready for the test. So you have a lot to work on. You have that assignment, you've got this lab, you've got the review sheet, you have a test coming up. The review sheet should get you ready for the test. So hopefully that helps on the lab. And again, if you have questions, email me or cohort B. I'll see you tomorrow. And I'll see A on Monday. And again, if you want to send me emails for questions, I'm more than happy to reply to those. Guys, have a good day. Be working on your chemistry. Fall break is still about 2.5 weeks away, so we need to work up to fall break. Hey, I'll talk to you soon.